The denominator of this algebraic fraction has a quadratic factor. It is not factorizable. In this video, let's learn how to obtain the partial fractions of such a fraction. We've learned how to obtain the partial fractions for this type of fraction. Here, the denominator is a product of linear factors. Another type of fraction has repeated linear factor in its denominator. We've also learned what its partial fractions look like. Now, look at this fraction. What are its partial fractions? Well, its denominator has a linear factor x minus 1, so there will be this partial fraction. What about this quadratic factor? Let's see. Is it factorizable? No. Is it a repeated linear factor? Also no. So how can we find the other partial fraction? Same as before, we must find the denominator and then the numerator. First, what is the denominator? Since we cannot factorize x squared plus 1, let it become the denominator. Second, what is the numerator? It is important to remember that partial fractions must be proper fractions. Since the denominator has degree 2, the numerator can have degree up to 1. So the numerator is of the form gx plus h. Now let's find the values of e, g, and h. As usual, we combine the two partial fractions together. Recall that these two fractions are equal, so we can equate the numerators. Then, we can use either substitution or comparison or both. Eventually, we will find that e equals 1, g equals 1, and h equals 2. So this single fraction can be expressed as partial fractions like this. Let's look at another example. Here in the denominator, x minus 1 is repeated, and there is a quadratic factor x squared plus 2. How do we obtain its partial fractions? Before we proceed, remember to ask, is this fraction proper? Well, the numerator has degree 3, and the denominator has degree 4. So yes, it is proper, and we can proceed. Recall that since x minus 1 is repeated, these are the corresponding partial fractions. And just as what we saw earlier, x squared plus 2 corresponds to this partial fraction. Next, we combine the partial fractions and then we can equate the numerators. We can then use substitution, comparison, or both to find the values of a, b, c, and d. Then these are the partial fractions. Let's look at one last example. Here, the denominator has a quadratic factor x squared minus 9 and a linear factor x minus 3. Does this mean that its partial fractions will be of this form? Note that x squared minus 9 can be factorized like this, so the fraction looks like this. In fact, there is a repeated linear factor, so its partial fractions should be of this form. So be careful when you see a quadratic factor. Check if you can factorize it first. Let's summarize. Look at this algebraic fraction. First, before finding its partial fractions, remember to check if it is a proper fraction. Next, look at its denominator. For the linear factor 2x minus 1, it corresponds to this partial fraction. Next, 2x plus 1 is repeated, so it corresponds to these partial fractions. Finally, the quadratic factor x squared plus 4 cannot be factorized further, and so it corresponds to this partial fraction. So we have covered all three possible types of factors.